Morning, everyone.
Good morning.
All right, good morning, everyone. I think I've got everyone marked. Just double checking real quick. All right. We're going to go ahead and get started. So yesterday we were working on proofs. And so I went through and I graded all your homework, and I made comments to everybody who turned it in. Okay, so if everything was right, you got a grade. If you had some errors, some things backwards, I tried to make comments to you about how to fix them. So I think we're pretty decent there, but I just want to point out, when you have your given statement and your proof statement, whatever that proof statement is, that is your absolute last step. There should be nothing after that. So you should be able to start every proof with all the givens, and you know the last step has to be whatever the proof statement is. Okay, so that was one big thing I noticed. The other thing is, make sure you're just reading carefully. Like, try not to go too quickly, because it's easy to quickly look at something and misread a triangle and an angle, right? Because they might have all the points in the same order, but they might have a triangle symbol instead of an angle symbol, or vice versa. Okay, so just slow down and make sure you're reading those carefully. All right, so we're going to build on that a little bit today, and I'm going to try to, again, give you that feedback again, because proofs, we do them a lot throughout the year, and if you don't get this good foundation, you kind of fall apart as we do proofs later on. Okay, so I'm trying to give you feedback as fast as I can, and there's no way to do like self-checking. So this is the best we can do right now. All right, so I did post notes. I posted it twice actually, because I had a bad homework assignment. So if you opened up my original homework assignment and things look bad, close it, because I deleted that whole assignment and reposted a whole new one. This is the Tuesday that we should just call done and try again tomorrow, I think. Wait, speaking of tomorrow, I am out tomorrow. Okay, I have an all-day meeting tomorrow, so you do not need to sign into Zoom, but there will be an assignment in Delta Math, okay? So I'll put a link on Google Classroom, but it's gonna be in Delta Math. All right, so let's go ahead and talk about what we're gonna do today. So we're gonna build on the proofs that we started yesterday. They're gonna be a little bit more complicated today, but not a lot. Like I said, I'm trying to just ease into something a little bit new each day. All right, so we're gonna start our proofs the same way. I have my figure over here to the right. I'm given that angle A is congruent to angle C. That's given. So I have angle A is congruent to angle C. And I have that AB is parallel to DC. That's given. So AB is parallel to DC. Now, notice here, I only have one congruency statement, right? I only have one. I need two more. This is not a congruency statement, but we can figure things out from this, right? So anytime you have parallel lines, it's almost always going to guarantee that you have alternate interior angles. That is, every time I see parallel lines, the first thing I want to look for is alternate interior angles. So up here, if I have these two parallel lines, this is, when we talked about this earlier this year, this is where you want to look for that. Oh, shoot. Hold on. Told you this is the day that should just be done. We want to look for the Z. Okay, so I made a Z with my parallel line markings. Okay, my alternate interior angles are the angles that are tucked into the Z. So this angle right here and this angle right here are my alternate interior angles. Okay, so I'm going to need to name those. So I have angle ABD is congruent to angle CDB. And my reasoning here is AIA, alternate interiors. Okay, now this is a mistake that a lot of people make. Everybody now wants to jump to the fact that this angle is congruent to this angle. Oh, let me get this out of the way. These two angles are congruent because of alternate interior angles. But that's not true. You have to base it on the parallel lines, and we've only been told that we have one set of parallel lines. Okay, now, the other thing is, yeah, the angles are going to be congruent. We could say that because of that third angle conjecture, but angle, angle, angle is not an acceptable side combination, so it doesn't really help us. Okay, so I know some of you are thinking that, well, of course they're going to be equal. You're right, in the long run they are, but based on our given information, that doesn't really help us, okay? So now, the next thing I notice, they share this side DB. Okay, so I know that DB is going to be congruent to DB because that's our reflexive property, or same segment. Okay, now I have three congruency statements. Okay, and I see my picture over here, I have angle, angle, side, and that's a good combination because I'm not swearing and I don't have AAA. So I have angle ABD is congruent to triangle CDB. All right, so this is the only new step at this point. As far as we started with parallel lines and we had to draw the conclusion that we have alternate interior angles. The other thing I want to point out on this proof, these two lines could have been flip-flopped. I would have to take the reasons with them, but one of them does not rely on the other. But this alternate interior angle did have to come after the parallel lines, because if we don't have parallel lines, then we couldn't have alternate interior angles. Questions on that? All right, let's look at the next one then. All right, so we have here a couple givens. We have WX is congruent to XY, that's given. So WX and XY. All right, and then we have XZ is an angle bisector. That's given. Okay, now there's no congruent statement right here. So that means we're probably going to be drawing a conclusion from that. Okay, so if this is an angle bisector, that means that these two angles are going to be congruent. So what I can do now is name those angles. I can say that WXZ is congruent to angle YXZ. And the reason I can say that is because I know what angle bisector means. So our reason here is just going to be definition of angle bisector. So anytime we have some vocabulary terms like angle bisector, midpoint, bisector, I think the other one's perpendicular. Anytime you see that, then what we typically write in our next reason, when we draw a conclusion from that, we just write definition of whatever that vocabulary word was. All right, so now I have two congruency statements. I need a third still. I know that they share this side. So I know that XZ is congruent to XZ. Again, that same segment are reflexive. Okay, so now I have three congruency statements. I look at my picture, I have a good combination here. I have side, angle, side. So triangle WXZ is congruent to triangle YXZ because of side, angle, side. Questions on that one? Okay, here's my next one. It says B is the midpoint of AD and EC. All right, so I have B is the midpoint of AD and EC. Well, I didn't even get one congruency statement on this one, but I can draw some conclusions from that because I know what midpoint means. So B is the midpoint of AD. Let's start there. So if B is the midpoint, that means that AB has to be congruent to BD. So I can say AB is congruent to BD. And the reason I know that is because I know what midpoint means. So it's just going to be definition of midpoint. All right, now it says B is also the midpoint of EC. Okay, so that if B is the midpoint of this segment EC, that means these two have to be congruent. All right, so that means that EB is congruent to BC, again, because of definition of midpoint. All right, then I have two congruency statements. I have 2 marks. I need one more so I can talk about my vertical angles. So this is what we did yesterday. We had vertical angles. So again, we have too many angles happening at B, so we got to name it with all 3 points. So angle ABE is congruent to angle DBC because of the vertical angle theorem, right? That's our vertical angles. All right, so now do I have a good combination? Yep, I have side, angle, side. I have 3 congruency statements, so I can make my last statement here. I can say that triangle ABE, so I'm just getting it from right up here, is congruent to triangle DBC because of side, angle, side. Questions on that one? All right, last one for today. So we have some givens up here. We have AB is congruent to AD. That's given. We have AC is perpendicular to BD. Okay, so we have AC is perpendicular to BD. All right, so now that is also given. Now, again, we only have one congruency statement. We know perpendicular means something, right? So that's a vocabulary word, so we're probably going to have to draw a conclusion from that. So we know perpendicular means that they make right angles. So what I can do is I can say angle ACB and angle ACD are right angles, because that's what definition of perpendicular means. So just by definition of perpendicular, I can say that I have right angles. Hold on, I'm gonna sneeze. Whew. Sorry, went away. Okay, I'm all right again. I'm back in the game. All right, so we have right angles here. Okay, now I have, they share AC. Okay, and I'm kind of seeing where this is going a little bit. If I have a right angle, then I have the potential of having hypotenuse leg. Okay, and I've also noticed that if I'm thinking about this triangle on the left and the right, I do have a hypotenuse, and I'm noticing they're sharing a leg. So I don't really need to go any further with this at this point. I could come back if I needed to say I had congruent angles, but we don't really have to yet. So I know that AC is congruent to AC, and that's because of reflexive. Again, or same segment. Okay, so this is one of those angle side sides, which we can't have. But because we have a right angle, we can use hypotenuse leg. So I can say that triangle ABC is congruent to triangle ADC because of hypotenuse leg. When you do hypotenuse leg, you only need two congruency statements, because you kind of make up for that third one by saying you have right angles. Oops. All right. Okay, so questions on that? Anyone need me to leave the screen up longer? All right, so for your homework tonight, you have 5 proofs. Okay, I put 5 on today. So this is what they look like. You have all the statements and all the reasons you need to put in order. Okay, so make sure you're starting with your givens. Start with your givens, build from there. You know that whatever the proof statement is, that has to be last. Okay, and the only thing you can put with the proof statement is one of our 5 shortcuts: side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. Now, there are extra pieces over here, and I can guarantee that because look, you have a side, angle, side here, and down below, there's an angle, angle, side. Okay, so make sure you're stopping and reading. Okay, so there's extra pieces today. Okay, there's extra pieces, especially in the first 3, not in the last 2. Okay, so that's what you're gonna work on today. Again, I'm gonna start hopefully this afternoon, start grading them and giving you feedback on your answers. All right, questions for me. Oops, questions for me. Okay, don't forget, I'm not gonna be here tomorrow. You don't need to sign into Zoom, but there will be an assignment in Google Classroom. Okay, so you're welcome to go, you're welcome to stay. You want me to post my notes that are finished?
Yes, please.
Yes.
Okay, I will do that. I'll do that right now. I'll export these and send them on to you guys, okay?
Okay, thank you.
All right, have a good day.
See you, Miss Wenga. Have a good
Bye.
day.
You too, bye.
Sorry about being late. I didn't
You're all
have a
good, honey.
period last period, and I honestly forgot. And then I looked at the clock, and I was like, "Oh my gosh."
Not a big deal.
Okay, have a good day.
Thanks, you too.